A'udhu Bismillahirrahmanirrahim. Today we are going to discuss raw materials, flowsheet diagrams and unit operations and unit processes of formic acid industry and its applications. Students, we are now going to discuss the contents in detail. In the previous two lectures, in the first lecture we have done introduction of formic acid. Then we had started production in the first lecture. We did start methyl formate hydrolysis, and the two processes which were used, unit processes which were used in methyl formate hydrolysis, carbonylation and hydrolysis. So the three processes by name, three processes we have studied. Only names were mentioned in the previous slides. The first one process was Kammer-Lennard process, and we have studied the Kammer-Lennard process in detail in the previous lecture. Now in today's lecture we are going to discuss the other two processes which fall in the category of methyl formate hydrolysis. Before going towards the other two processes, BASF process and USSR process, just a brief review of the Kammer-Lennard process. The few points which are very important to go through and study in BASF and USSR. So I just want to review what we did study in Kammer-Lennard process. So we did study that in the Kammer-Lennard process we have done carbonylation. So the carbonylation which we have done, that was done in reactor A. Three reactants, carbon monoxide, methanol and catalyst were fed into reactor A, and then they were further sent forward into reactor B. To here in the reactor B, we have discussed that in the reactor B, what was done? Methyl formate, which was produced by the reaction of the reactants in reactor A, that was all the discharge from reactor A was fed into reactor B. That is mentioned as methyl formate reactor. So methyl formate, which is drawn off as a distillate from that reactor B, that is called, like A reactor, methyl formate reactor, and B is the methyl formate column. You just draw methyl formate from that column B. Now from column B, when methanol and the dissolved catalyst are returned back from column B to the methyl formate column B, that is B reactor column B, that is methyl formate column, from methyl formate column they are sent back to the methyl formate reactor. Now then we have seen that catalyst is inactivated catalyst is crystallized and discharged from here. Off gases or any waste gases are off gases from column B, and waste gases from the reactor A, they are just burned. Then we have seen that the methyl formate, which is taken from, which is just collected from reactor B, that is sent to preliminary reactor C. Then we have studied that discharge from the preliminary reactor is fed into the main reactor D. So in the main reactor D, we have also sent some of the recycled methyl formate, methanol also. Now we have studied that water, methyl formate and methanol, the recycled ones, from where are they coming? We shall be going to see them in the we have seen them in the afterwards column or reactors. These recycled ones, three things which we have added in reactor D, the main reactor which we did call. Now from the reactor D, what happened? The contact time was increased, equilibrium was established, then reactor discharge like formic acid which has been formed, and along with that, if reactants are there, they are flashed into flash tank, that is E. Now methyl formate, methanol and small quantities of formic acid, they were evaporated in the process, they were recycled to main reactor D. So that was what I was saying, that methyl formate which was collected from B has been fed into C, preliminary reactor, that is fed into D, and some recycled materials. These recycled materials actually come from reactor E, where we are just we have sent we have flashed the reactor discharge of main reactor into the E. Now, so we have discussed A, B, C, D, E. Now after that, methyl formate, methanol and small quantities of formic acid which are evaporated, they are sent, they are recycled to the main reactor. From here, after going the reactor discharge when is fed to E in the flash tank, the sum of the methyl formate, methanol or small quantities of formic acid evaporate, and they are then sent back into the main reactor. Now methyl formate and methanol are distilled in vacuum in the acid separator column. They are in the next column, that's name is acid separator column. So methyl formate, one of the product of first reactant, first unit process carbonylation, and methanol, the reactant of carbonylation process. They are, as we have said, that we have fed all the methyl formate which was produced from methyl formate column, we have fed into C, and along with that the recycled materials we also have fed into D. So from C, methyl formate, and the recycled material methyl, any recycled material like methanol or water, we have fed into D. So after D, we have flashed the materials into E, and after flashing we have done what? In the acid separation column, we have done, in the acid separation column G, we have done the distillation of methyl formate and methanol, and in vacuum we have done the distillation to separate these. So they are distilled, methyl formate and methanol. As we know that their boiling point, methanol's boiling point is about 70 something, methyl formate as is the ester of formic acid, so it must be having lesser boiling point than formic acid. So both of these are just distilled in vacuum in the acid separation column. Now what happens in the F? This acid separation column, the contact time is minimized by the internals. With a small liquid hold up, the distillate is separated in methyl formate and methanol in the recycle column. Now we have done the distillation in columns, in acid separation column, and then we have separated the distillate in the recycle column F. So F is the recycle column. Like if you see that, if you recall that D, after main reactor there was E, after E there was F, and after F there was G. With the separation, but we directly fed the materials from the products, reactants from the flash tank into G rather than into F. From G, there is no direct contact between E and F. So from G, we have fed the materials into G, and their vacuum distillation took place, and from that distillate, methyl formate and methanol are separated in the recycle column F. So F is the recycle column. And after that, what happened? The product is, the distillation is now done in is controllable processes done in two columns, H and I. In H, first water is distilled, and the concentrated product at the bottom is the formic acid, but it is further concentrated up to 98 degrees centigrade in the next column. In H is the first product column and I is the second product column. So in the second product column, formic acid with a maximum concentration of 98 weight percent is drawn off as a distillate. The bottom product is recycled to the first product column. The bottom product is recycled to the first product column. So the bottom product is recycled to the first product column. The first product column is H, and that product which is left at the bottom product is then again recycled to the first product column for getting more concentrated formic acid. This was all the review, and I have reviewed all that so we can easily understand the next processes, the two processes which we'll be discussing in the next slides, BASF process and USSR process. This formic acid plant began operating in Ludwigshafen, Germany in 1981. In this plant, a technology for the hydrolysis and dehydration was used for the very first time. Now, the production of methyl formate by carbonylation of methanol has been carried out on a large scale for many years at BASF. The carbonylation stage is largely identical to that of the Kammer-Lennard process, but the hydrolysis stage and the dehydration of formic acid are noticeably different. First of all, we have seen that BASF process was a plant of formic acid. BASF process 1 plant began operating in Germany in 1981. In this plant, hydrolysis and dehydration, both technologies were used for the first time. Now the production of methyl formate by the carbonylation of methanol, that has been done for many years at BASF. On large scale it was done. So carbonylation state is largely identical to that of Kammer-Lennard process. It's the same, quite identical. With the hydrolysis stage and the dehydration of formic acid, that was the second step in Kammer-Lennard process. Here also second step, but that is a different one from the Kammer-Lennard process. In this classical BASF process, hydrolysis is carried out with large excess of water. So if we remember, if we recall basically, when we have discussed the unit processes in the start of the production lecture, we have seen that hydrolysis of methyl formate process, we have discussed a bit that that can be simply gained by the reaction of water and carbon dioxide. We can get formic acid, but we do not get it because that is equilibrium is not favorable for that reaction. So we did say that first the practically possible thing is that first we do the carbonylation and then hydrolysis. And in the hydrolysis step, we have seen that that reaction was also unfavorable, also having unfavorable equilibrium. So we thought about two options for that favorable equilibrium. Actually, the word we thought should not be used. Industrially, it was seen that two options were applied for the this reaction to move to the forward direction. One was that if we use plenty of water, according to the Leach-Etter principle, we discussed that if we increase the reactants, the reaction will of course go to the product side. But then along with that, we have seen that removal of water was the energy efficient process needing. Like to remove the water, there were energy efficient processes were involved. So another option was also discussed over here, that we can use a base that can make a complex with the formic acid formed, and then we have seen the cares we should take for that base and some points regarding that. So the same here in the classical BASF process, hydrolysis is carried out with a large excess of water, and the ratio of water as compared to the methyl formate, there are 5 moles of water per mole of methyl formate. Like 1 mole of methyl formate is if produced, then 5 moles of water are there for that 1 mole of methyl formate. So what happens then? Simply methyl formate, for the hydrolysis of methyl formate, just the reaction is the hydrolysis of methyl formate. So when 5 mole of water required for or water is then required for the hydrolysis of methyl formate, if we are using 1 mole of methyl formate, then we need 5 moles of water for the hydrolysis for this reaction. So if we, by doing this, excess of water we use for the hydrolysis of methyl formate in BASF process, so they will just shift the equilibrium in the direction of formic acid, like in the direction of the product. Okay, in the Leach-Etter principle, as we have discussed before also in the previous lectures. Much of the water is separable liquid extraction with a secondary amide, So in the previous process you have seen, Kammer-Lennard process, you have seen that distillation was being used, vacuum distillation was being used for the separation of formic acid and water and methyl formate, if the remaining methyl formate and methanol is left over there. But here liquid extraction is used for the separation of water with a secondary amide. Liquid extraction and secondary amide is also used over here for the liquid extraction process. And if I just recall, and you just think about that, we have studied in the first chapter, the first part of the industrial chemistry course, unit operations and unit processes. We have discussed one of the processes, like liquid extraction was also there. So liquid extraction, simply that if something is mixed, two miscible liquids are if there, and we are adding another liquid, and one of the liquids is more soluble in that liquid which we have added afterwards. So that one which is more soluble in the liquid which is added afterwards, that will go into that liquid. So the same strategy is applied over here also. The water is separated by liquid extraction with a secondary imine. So simply I can say that we have seen in the BASF process, carbonylation is just similar to the Kammer-Lennard process with hydrolysis stage, and dehydration of formic acid are different. If here we use excess of water for the hydrolysis of methyl formate, and then we separate that by the use of separate the excess of water from the reaction by the use of liquid extraction with the secondary imine. Now here what process is going on? The diagram on the right hand side is in front of you, quite similar to the diagram of Kammer-Lennard process. Now you can see here that carbon monoxide and methanol, they react in the methyl formate reactor. So first one is the reactor which is labeled as A, in which the carbon monoxide is being added, and along with that catalyst and methanol are also added. So this one is the methyl formate reactor. In methyl formate reactor, we are adding carbon monoxide, we are adding methanol, and also we are adding sodium methoxide. Now methyl formate, which is produced in this reactor, is fed as a distillate from the methyl formate column into the formic acid reactor. Same as we have seen the methyl formate, which is formed in the methyl formate reactor, that is fed as a distillate from this methyl formate column B into the formic acid reactor. If from A it goes to B, where it is distilled, or the distillate for methyl formate distillate from the methyl formate column B, second one column labeled as B. As you are looking an arrow from A to B, that is showing that the methyl formate which is produced in reactor A is fed to the methyl formate column B, and where it is in the form of distillate is fed into C. And along with that, recycled methyl formate also comes into C, which is hydrolysis reactor. Methanol and dissolved catalysts are drawn off from the bottom column B and returned to the reactor A. So methanol, or if any catalyst is left, as a dissolved catalyst is present, they are drawn off from the bottom of methyl formate column, and they are returned to as you can see, there is an arrow from the bottom of methyl formate column, and that is moving towards the left hand side and then going back to the arrow which is moving into methyl formate reactor. So Now, as we've seen that methanol and dissolved catalyst are drawn from the bottom of the column B, and they are returned to the reactor. Catalyst decomposition products are discharged by crystallization. We do the crystallization of the catalyst decomposition products, and they are then separated away from here. So mainly the first one, methyl formate reactor, is the same. The second one, where the methyl formate in the form of distillate is fed into C reactor. Here it is called hydrolysis reactor. So the methyl formate column is also the same. But now as we are seeing that the hydrolysis reactor is C and methyl formate is fed into C, but methanol or dissolved catalysts are drawn, and they are from B, and they are returned to A, and the catalyst decomposition products are discharged. Now what happens in reactor C? The methyl formate is hydrolyzed with excess of water at elevated temperature and increased pressure. Now the difference again, that at high temperature and pressure this reaction is going on, producing excess of water. The reaction product is flashed into low boiler column. In the reactor, in the hydrolysis reactor C, elevated temperature and increased pressure are used, and excess water is used to hydrolyze methyl formate. As we have seen that why excess of water is used. Now you can answer very easily that what excess of water for moving the reaction for forward direction. So the reaction product is splashed into the low boiler column D. Next column D, which is called low boiler column, or reaction product is splashed into that. What is the reaction product of methyl formate hydrolysis? Of course that will be formic acid and methanol. So methyl formate is removed as the distillate with methanol as a side stream, and dilute aqueous formic acid is drawn off from the bottom into the extraction unit. Now E, which is labeled as extraction unit. We are having methyl formate, unreacted is there. We are having methanol as a product. We are having formic acid as the product. And we are having excess of water over here. So now methanol or methyl formate, they are removed as a distillate from extraction unit, and extraction unit is E. These both are collected as distillate, and dilute aqueous formic acid, that is formic acid with having excess of water, is drawn from the bottom, and that is sent into the extraction unit. Now here the formic acid and some of the water are extracted by secondary amide. Now the extraction of formic acid and some of the water is done by secondary amide. Also most of the water, largely pure formic acid, is recycled to the reactor C. So the water which is separated from which has come from extraction column, that is that is not extraction column, that is extraction unit. From extraction unit the water and formic acid has come, so they have been extraction has been taken with, has been done with secondary amine. So the water which is free from formic acid. Formic acid has been extracted from there, a small amount of water, and formic acid has been extracted by the use of the secondary amide. So the most of water which is free from the formic acid, that is recycled to the reactor C, hydrolysis reactor. So here we discuss that what happens in hydrolysis reactor, the conditions in the hydrolysis reactor were elevated temperature and increased pressure. Then from hydrolysis reactor, the reaction product was fed into low boiler column. Here in the low boiler column D, the reaction product is flashed from reactor C. Now methyl formate is removed as a distillate with methanol as a side stream. Here in D, what happens? Here in D, methyl formate is removed as a distillate and with methanol as a side stream. So if you look at D, what is happening over here? Methyl formate and methanol, which have been distilled from this D low boiler column, they have been sent to the B. There is an arrow going from D, that is joining an arrow from B, and that is they both are going into C. C is the hydrolysis reactor. So methyl formate which is taken away, or methanol which is taken away, they are just going to the hydrolysis reactor. Now the dilute aqueous formic acid that is drawn off from the bottom into the extraction unit, that is sent into the extraction unit E. So this should be very clear that at the bottom there was formic acid, dilute formic acid, that is fed from D into E, and you can chase the way by an arrow moving from the bottom of D to the side of E extraction unit. Now in the extraction unit, what is happening? In the extraction unit, secondary amide is being used for the extraction of formic acid, and some of the water is also extracted along with that, but most of the water which is free now from formic acid, that is recycled from extraction unit E to C, where hydrolysis reactor is there and the hydrolysis is taking place. So the mixture of extractant, formic acid, and some water is still in the dehydration column F. Now you can see from the extraction unit, the extract which has been consisting of extractant like amide, formic acid, and some water, that is distilled in dehydration column. It is distilled in F, dehydration column. Enough water is distilled via the head of the required formic acid concentration to be obtained in the pure acid column G. Then water is distilled via the head for the required formic acid concentration. How much water is to be removed or to be distilled? That depends upon the percentage composition of formic acid, like how much weight percent of formic acid is needed. So in the pure acid column, the water which is distilled, that is taken away. So that is done in dehydration column F. So the acid, which is to be concentrated, that goes into that to be obtained, the concentration of the formic acid to be obtained in the pure column. So enough water is distilled by the head for the required formic acid concentration to be obtained in the pure acid column G. Now, so we have seen the extract, a mixture of the extractant and the formic acid in some water that is distilled in the dehydration column F. And then we have talked about the column which is pure acid column G. From the dehydration column we have moved to the column pure acid column. This column is operated in a vacuum. The extraction agent is recycled from the bottom of the column to the extraction unit. From the bottom of the column, pure acid column, the extractant the extraction agent is recycled here. Then distillation in two columns is more industry controllable. Water is distilled overhead in the first product column H. Okay, sorry, this point was of the previous the last one point which I talked about, the point like two distillation columns have been used. That is the point of Kammer-Lennard process. So if you remember that, so there was the two columns for the dehydration basically. So this is the main difference of Kammer-Lennard process and BASF process. In the BASF process, this step hydrolysis is different and the removal of the water is different a bit. So now we see that BASF has developed new technology in which a complex former such as tertiary amine is used to shift the hydrolysis equilibrium and to reduce the amount of water that needs to be evaporated. So the thing is that now, as we already have discussed this point in detail, that there were two options: either to use water in excess to move the reaction to the forward direction, or there was a suggestion of using some base that can make an adduct with the formic acid to move the reaction in the forward direction, as product will be moved into the adduct, and there will be a decrease in the concentration of the product. So for increasing that product concentration, the reaction will move in the forward direction. So this technology has been developed by BASF, this new technology of the complex formation. So they used tertiary amine for that complex formation, so that the hydrolysis equilibrium should be shifting in the forward direction, and due to the drawbacks or due to the problem of removal of water, so that amount of water that was needed to be evaporated was quite in excess. So they just wanted to reduce that, and so they introduced the tertiary amine used for the complex formation. Now here is the comparison of the Kammer-Lennard and classical BASF process. You can see the major differences in a methyl formate reactor is same in both. Methyl formate column is also same in both. C, preliminary reactor and main reactor. There are two reactors in Kammer-Lennard process, but in classical BASF process there is only one hydrolysis reactor. Then from preliminary reactor, the feed goes to the main reactor, and then it is fed into the flash tank, and then to the recycle column, and then acid separation column. But here in the BASF process there are 4 columns, but in those columns D, E, F and G. But here in those columns, this D is called low boiler column. E is the extraction column. A new column is introduced. That is an extraction column. Before that, in the Kammer-Lennard process, the flash tank was there first of all. Then there was a direct link of flash tank with the E with the G. There was no direct contact of E with the F, but from F whatever was being recycled, that was coming back to D. So this is the difference over here in BASF process. From D, the feed is going towards E, the extraction column, and then it is moving forward into F, dehydration column, and then the concentrated separated or extracted acid, small amount of water is fed into pure acid column. So the difference is that in Kammer-Lennard process 2 columns have been used for the distillation. First product column, here water was mainly distilled, and the second is the second product column. First product column H and second product column I in Kammer-Lennard process. But here only dehydration column is the F1, where water is majorly before that water is removed in extraction column E, and then it is dehydrated in F dehydration column, and then pure acid is further the quite concentrated formic acid is obtained in this way. Now the third process, USSR process. Hydrolysis is carried out under atmospheric pressure in a column that is divided into 2 zones. So actually we have discussed this before, that the major difference in all the processes is of hydrolysis. The first one is about identical in most of the processes. So in the USSR process, the hydrolysis is carried out under normal atmospheric pressure, but in a column that is divided into 2 zones. So water is fed from the upper zone. It contains a fixed bed of strongly acidic ion exchange resin, and that is at temperature 60 to 100 degrees centigrade, the upper zone, which is fed with water, and it is containing a fixed bed of strongly acidic ion exchange resin. Methyl formate is fed from the lower zone, which is kept at 100 to 107 degrees centigrade. Now the hydrolysis is catalyzed by the resin in the upper zone and by formic acid in the lower zone. So in the lower zone, where there is methyl formate, here the formic acid catalyzes. As it is formed, it catalyzes the hydrolysis of methyl formate. But in the upper zone there is water, and that is with the help of that resin. Over there in the upper zone from 60 to 100 degrees centigrade, the ion exchange resin, that is strongly acidic ion exchange resin, is catalyzing the hydrolysis. So most of the methanol and unconverted methyl formate, they are taken out from the top because they are having less boiling points, and formic acid and water from the bottom, as they are having their boiling points are a bit high. Then methyl formate and methanol. So there is the difference of all that. So in the hydrolysis zone, in the hydrolysis column, there are two zones: upper zone and lower zone. Upper zone, water is fed. There is a fixed bed of strongly acidic ion exchange resin, and the temperature is kept at 60 to 100 degrees centigrade. And the lower one, as the temperature of the lower one zone is 100 to 107 degrees centigrade. Here methyl formate is fed into the lower zone. Hydrolysis is catalyzed in both of the zones. In the upper zone it is catalyzed by the resin, but in the lower zone it is catalyzed by the formic acid itself. So unconverted methyl formate or methanol are taken out from the bottom, from the top, but the formic acid and water are taken from the bottom. Now at the end, I just would like to have a small review of that we have studied in this lecture, and then assignments. In this lecture we have studied the main process, methyl formate hydrolysis. There were three processes. So one we have discussed in the second lecture of oxalic acid, and the two processes BASF and USSR we did study in this lecture, and along with that we have compared Kammer-Lennard and BASF process and USSR process. We have also studied the major difference of USSR from the remaining two processes. Sorry, USSR, not USSR, USSR. And now there are assignments given to you. One is that how flash tank, recycle column and acid separation column are related to each other in Kammer-Lennard process. Now the question here is asked that how the reactants or the products from one column to the other will go or move on, which one comes first in these three, and from where the products are moving to where. So you will have to show a link diagram or along with the description for these three. Assignment number 2 is discuss the advantages and disadvantages of different hydrolysis unit process in methyl formate hydrolysis method. In methyl formate hydrolysis method, you should know that how many hydrolysis unit processes we have discussed. So just recalling them, then recalling the disadvantage or advantages of all these processes. You will just brief this assignment number 2. You will tell that when we hydrolyze methyl formate, so different unit processes are being used in these three processes. So what is the difference between them, and what is the advantage of the difference? If someone is having an advantage over the other, or what is that advantage? If someone is having a disadvantage over the other, and what is that disadvantage? And check the assignments, try to do them. Hope so you will do. If you will not be able, you can discuss, you can ask. Thank you.